Okay, let's start. Hi, everyone. Thanks for coming to this month's webinar, which is going to be about Spider-Man and web testing. There's a few reasons I'm doing this, and I'm doing this now, but the thinking about it was like, well, we've been using the web like for 30 years now, so we probably know what web is. We know what testing is, because even if we're not testers in our day job or writing tests in our day job, we have a sense of actually testing applications because we've been using them for a long time. So this thing is not about understanding what is web testing, but it is about the methodology, how to approach these things, and especially in the current modern environment where everything's complex, use all kinds of frameworks. So I'm going to talk about this and show you examples. And if you have questions, put them in the Q&A box. I'll try to answer them either as we go or at the end. And I hope this is going to be beneficial for you. So my name is Gil. I do webinars. I'm also trainers and consultants about everything's relating to creating better software. And that means about testing, about development, code quality, all kinds of testing, automation, and everything in between. There's a couple of books that I wrote, and you can get in touch with me through the things that you see on the screen right now, or going to the site. Want to mention that there are a couple of things that I'm doing that are related to what I'm going to talk about today, which is introduction to web testing, introduction to developer web testing, which is kind of a compound course for everything that a developer should know when they're writing web applications. New course about testing with Playwright, and it's going to be a lot of web-related content testing, web testing related content, as we're starting to move on, probably also webinars. So if you're interested in help or training or some kind of mentoring around this part, let me know. I hope I can help. Okay, so what I did is I built an application and I want to test it. So let's switch to Visual Studio Code. And this is my application. Basically, it's a registration page. You see that this is the main page, has a title. All this here is built as a React component. It runs locally, like I said. You can see it from the address bar. It has a local database. Actually, it's a file database. So everything runs locally. Like I said, you have to put in the first name, last name, email. When it comes up, this checkbox is checked. The register button is disabled. I have to check that I've read the whole term sheet and agree, meaning the term checkbox, in order to enable that. If things are either empty or the email is not correct and I press register, it gives me an error here. And if I actually put something in like Gil, and let's fix my name and write the right email, and I press register, can see that it's actually running and compiling, and it says, "Thank you, Gil." This is the entire application. It actually works. I tested it. So the question is, I'm going to switch back to, you see all kinds of things there. There's the validation, there's the behavior with the enable and disabling of the button, and the error thing, the whole process. does it really work? So how do I know that it works? I'm going to test it. I need to know what are the expected results of these things. So if you think about it, what we saw in terms of the UI was like switching pages. I went from the registration page to the thank you page and told me, thank you, Gil. So, and this is a register process. So obviously it works, right? Not really. We can't trust the thank you page. We actually want to know that the registration, or at least saving the data, storing the data, was actually done. There's another side of that that we not always directly think about, because this is what we call the happy path. The second path is when I clicked the things that created the error, like the empty stuff, it makes sense for us, like users, that it doesn't store anything when we did that. But actually, I pressed a button. Maybe it did store things in the database. So something that is working, to what kind of definition of working are we talking about? And even if it didn't work, how do I make sure that it doesn't work? If I just test it from the screen, from the browser, and I've done this manually, and of course, we'll talk about how to do this automatically. Just running through the screens, there's some information that is not exposed to that. When thinking about testing and web testing, our starting point was, how do we know that things are actually working? And the answer may not be on the screen every time. So we actually need to go deeper. Let's talk about the architecture of how this works. So this is like basic architecture of like, and if you've seen my other webinars, you may have seen this before. So we have client code. The client code is it's a Next.js application, so it's written in JavaScript and TypeScript and like a web server all by itself. The UI is a React components or React applications as well. There is some kind of server code, which I'm going to show you in a second, that stores data in the database. The database itself, this is like a JSON database. I'll show you in a second. It's like a local database, which you probably wouldn't use regularly, but I chose to write my application this way. So like this is like regular architecture. It's made of web pages, HTML pages, and components, which we'll talk about that. Components like most modern applications today for the web are written by some kind of framework. I used React, but you can use Vue or Angular or whatever. And we'll talk about what components are and what it means actually testing them. So, but what we see from the outside in are like this part here, the client. But our application is made out of different things you see on the screen. So let's look at the code itself a bit. So how it looks like I said, this is a React Next.js application. So this is the main page. You see it on the screen, the registration page. It actually handles the submit. So if you're looking at, let's get back to our main page here. So this here is the React component, what we call the registration component. And everything here is like interaction with the user, collecting the information, but doesn't talk to the database. So when I actually press the register, it actually, the register button, it creates an event, sends it to the page, the container, and the container submits the data through an API. So what we have in terms of pages is this page, which is the container of the registration. We also have the thank you page. We'll talk about that later. We have a few components. The registration is the most important one here. There's also, I created a details class just for the data, the first name, last name, and email that is collected from here. It doesn't collect data from here. We'll talk about that too. And there's a validator, which I could have done inside the registration component, but why do that? It will make our life easier later when we're testing. So this validator checks that things are not empty and the email is some kind of a weird regular expression that translates into an email, a valid email thing. So that's the code. Well, there's some kind of sort of black and white CSS things. I use Tailwind for that for like the design, but it really doesn't matter because what we're really interested most of the time is the behavior. So why is that important? Well, we know what it needs to do. Now that we know, oh, I haven't showed you, this is the database here. Remember, this is the last record that I've collected, the things that I actually sent. So this is what actually work. This was what was there before that. So now that we know how things are built, it's easier to think about a plan, how we're going to test stuff. Because now just looking from the outside doesn't help much. I haven't showed you, it is the API itself, the register API. This is the code that when we press register, the register raises an event to the page called this API, this post API here, which stores the data in the database. We know how it works and we know how it's built. Now we can start thinking about what are the cases that are interesting for us. So obviously there's the big happy path that we're talking about, the whole process of entering data and knowing that we actually save the data. But there's also all kind of validations, the validations of the content of the text boxes. There's this kind of the thing about this, that it loads with disabled, but when I click it, it enables. And this weird information if I want to get promotions, we'll talk about what it means, but it's basically, that's just a checkbox. But we can start devising some kind of plans. And it's very important to understand that because this information that we have, the knowledge of how this thing is built, is giving us ideas how to check that it actually works. Before that, if I just showed you the pages, you will say, well, only thing I have is a thank you page. It's not enough. Okay, so yeah, we talked about different kind of cases, the validation, interaction, but because we also know that there is something, the saving is done in the through an API, we can write a test for the API, which I haven't done today, and we can check that separately, and we can because things are like sort of separated, the validator class, the registration component, we can test everything from the UI, the like end-to-end tests. First, it's not going to be enough, but it's going to be very slow. And there's a reason, sorry. The reason we're doing that is kind of separating things that we usually do kind of automatically or implicitly, is that we have come up with the cases, and then we need to decide that's the what part, what we're going to test. Then we need to say how we're going to test it. And it's different because the architecture really impacts our decision, and our decision really impacts how well we're going to test it, because there's this. Now, the people who've seen the pyramid before, the testing pyramid before, probably heard all the stories. I'm not going to make a very big story about this today. You can find out in the YouTube channel. There are videos about this as well. There's a reason the pyramid still exists. It may not work for everything, but it does make sense. And the sense that it makes is, first of all, for people who haven't seen it, it means that out of all the tests that you should have, you probably need more unit tests, an API test, more API tests than UI or web tests, whatever your UI is. And you can have different stages in there. And sometimes you'll see it as a diamond, but not today. The reason it's a pyramid is that this is a pyramid of cost. Unit tests are easier to write and cheaper to run and cheaper to debug and maintain because they're very small setup, and they check very bits of pieces of code, and for bits and pieces of code you don't need much. Going on top of the pyramid, an end-to-end test. These are generally harder to write. I say generally because once you have like the happy path, and then you like trying to do modification of that, the residual or the marginal thing is not that big. But generally, getting to the first step does take time. But it costs a lot first in running. These are slower tests, and they're a lot more fragile because we're running all kinds of things in the middle, apart from our code, and everything of this thing and any combination can fail this. So they are hard to debug, they're hard to maintain, they're fragile. We don't like them. We really like them when they pass, but other than that, we don't. So this is the pyramid, and if we're talking about, if we wanted all the tests that we have to make sense to us, and if there was a guarantee that they were always passing, and they were very cheap, I'll probably do everything from the browser if I can. But since I can't, there's no guarantee for that. I'd rather like just separate my effort on the different stages and see what's actually working, and when they are working, spend as much time working on the tests, the smaller tests that give me confidence that the smaller bits work, and maybe leave the big effort for the happy path or whatever we call it, and at least one test going there, and then we might have even redundancy of coverage, that we have different types of tests that checking different stuff but going to the same code, and then if one of them fails, we know that the problem is not with this part of the code but in this one. So this is test design. We're deciding what to test where. So if you think about it, obviously, and I've done the first step for you because I'm this generous, the whole validation part, it can be done, it can be separated to different code. If it can be separated to separate code without UI, without talking to the database, it can be, by definition, tested very easily, like a unit test. And obviously this validator code can benefit from unit tests. I'm using vtest, by the way, because I wanted to play with it. What we're talking about today is the examples are going to be in JavaScript and TypeScript, but this is true for everything. Whatever backend you have, whatever front end you have, you can find a test framework that works for you. There's also one thing that I designed the system to have, and that is the component, the registration component, doesn't talk to the database, only the page does. That means it's easier to test the component because we don't have to mock anything or to supply some kind of a response or run a database so it can actually work. So actually designing the application, designing the code to be what we call testable, helps us with the design of tests and finding and covering more cases in a way that basically let us sleep better at night. So we have the unit tests themselves, the registration component, it's a React component. I'm going to test it with tools for components. That's going to be vtest as the test framework. I'm going to use a React testing library, which is very useful. I'll show you an example in a minute. And the end-to-end thing, the whole registration process, I'm going to automate with Playwright, Selenium, Cypress, whatever you use, and that's basically it. So I have to like a whole bunch of cases. I need to select, to choose how I'm going to write these tests and how. And I help myself because I'm that good and I'm that generous by designing the code to make it more easy to test. If whatever we already also all experienced the wrath of legacy code, it's going to be a lot harder to do these things. So why not do that? But before that, I'm going to talk about like what are component tests and what are web tests. So because they all fall in the same category, because at the end it's just HTML and JavaScript created. But the tools that we're talking about today and the way we develop software like frontend today is made up of components, which makes a lot of sense because like we've been doing components in backend in Java and C# and C++ like for years, so 50 years. So it makes sense that we won't have to test everything, just load what we're interested in. If we can do that, we can ignore all the rest of the stuff and check just what this thing is doing. So component tests basically check that a piece of the code, our React component, really translates into a bit of JavaScript and HTML. And when things happen dynamically, this DOM, the document object model, changes, and we can check that. Only this part of HTML, it's not like full HTML, it's not valid HTML because it's not a full page. So a component needs something to run in, which is a test bed or a container. And in Angular, it's actually called a test bed. And basically, whenever you're using a testing library, this is what it does. It's basically loads and transpiles the React code, in our case, into JavaScript and DOM, and kind of creates like a page that contains that. And we check that this is the white path here, that this translation from React code to HTML and JavaScript works correctly based on what we actually want. So the test framework will run, that could create a test bed and load the component into that. In web tests, we're talking about full pages. And since full pages need to run somewhere, but usually the excellent choice for that is a browser. So in Playwright and Selenium, basically we're talking about automating a browser that loads the entire page. Remember, this page doesn't have any concept of components in it already, because it was already, like, everything was already thrown into a bucket called a page, and it looks like this, regardless of how it was built. So everything works together, and we're testing that and everything beyond that, because like we don't know what's happening beyond the server, which, like in our case, it might be very interesting to see what's happening in the server. So it looks the same. They look the same component to the web test, but they're actually testing not exactly the same thing, and definitely not in the same way. So let's take a look at the validator. So this is the validator class. Like I said, it's TypeScript class. Only logic. It doesn't have anything UI related here. So basically just conditionals and throwing errors if needed. It has the main method called validate details, and it calls internally is empty for the first, well, all classes, all text boxes here, and also checks that the email here is invalid based on a regular expression that I copied from the internet. I don't know if it works, need to test. As I was actually testing it, I found out there was an error somewhere in my code, which makes sense because it's good to test. So how do I test this? So I have a unit test. Like I said, this is a V-test, the framework for run test, and I used that after using Jest, and I found that it's just like Jest, only simpler to configure, which is a very big plus. So what kind of cases? So let's go over that. So if you haven't seen a test on a test framework in JavaScript before, a test suite is called a describe, gets a string and all the tests in it. A test could be it or test, and it has a description. This one is I'm checking the isEmpty, the smaller method, that it reports correctly strings. Basically, this is calling the isEmpty static method. and I'm making sure that either it's empty or full of spaces, it returns true. And if it has something in it, it will return false. Basic unit test. The other one is checking that the email is valid. I can check that, and remember what I'm checking is invalid email, which is a kind of a the conditionals, the nut things are really nutty. So an empty email is invalid, something that doesn't look like an email is invalid, and something that does look like an email is not invalid, which means it's valid. And then I'm checking the containing function, and I need to do this in two ways. The first one is that if all valid details are true, there's no error thrown. Look at the code. Where's my code? Validator. Zoom gets in the way. Validator. Yeah, thank you. So this method, this function throws an error if something is wrong, but doesn't do anything if everything is right. And I want to check that, and I can do that in a unit test as well. So how do I do that? There's a pattern for that. I'm using a try-catch clause. I'm trying to run everything correctly here. If everything runs correctly, it doesn't throw an error, doesn't get to this part of the catch, and everything is okay. So this is like a pattern for unit testing if you want to check that an exception isn't thrown. Obviously, today we have most frameworks come with something that can actually check that, and this is like we can use the expect. This is the other case that if there are invalid details, remember when something is starting out in details, everything's empty. So I'm calling the validated details and expecting it to throw the invalid data. That's basically the behavior of the validation. And now that I've done this, I can go to the component level. Remember, all this is the component. And check things with or without the validator. Today I'm going to do this with the validator. If it actually bothered me, I could actually mock it. Not going to do this. So how does a component test look like? So first let's look at the code. So this is like a React code. If you have seen something, Angular is pretty similar in that. It has all kind of HTML in it. It's called JSX, and all kinds of functions. What is interesting in here are basically the cases that I actually want to do this. And I separate them into two parts. The first one is when the component is come up. Let's look at the test. So startup, when it is created. Remember, this component as it is now does not talk to anything at all. It only talks to its container by sending an event. It doesn't call an API or something like that. If it would, I would actually need to actually do something about it when I'm testing it. The way it works, like I said, is I'm checking. Let me squeeze that back again so we'll have more real estate here. And look at the code. VTest as the test framework, and I'm using the testing library for React. There is something similar for Angular, Vue, anything. And the way we do this is we render the component. This is what it actually says is for people who don't speak React. Render the component, and I'm passing in a property, the event handler, which is a mocked function. We won't do this much now. Later we'll do, because currently we're checking what happens on startup. On startup, nothing happens. What happens on startup? So there are a couple of things happening here that I kind of translated from the page level to the component level, because this is something that we need to do. If this is not the case, maybe it's not going to be that important to test these things that they happen on startup, but this is like a bunch of cases that are interesting to me to make sure that are still working. So what do I check? I'm going to check that the first, last name, and email boxes are empty. And basically what we do is we use the testing library to find the elements called locators. There are different ways to find them. And once it's rendered, we can actually find them, looking for text boxes. And these are these three, and all of them, I'm running a for each one of them that they have text content which is empty. This is what I want. On startup, what else do I want? Checkbox are checks. The checkboxes are checked correctly. Remember that what I told you is that when things are loaded up, it looks like this. So the I want to get promotions checkbox needs to be checked, and I have read the whole terms sheet should not be checked. So this is what I actually do. That I find the checkbox that has the text I want to get a promotion too. So I put it in a constant. Why? Because it makes life easier for me to reuse that. And if I change that in the production code, test still works. So I'm looking for the checkbox with that kind of text, and I make sure that it is checked. And then I look for the other ones, the terms text, which is I have read the whole term sheet and agree. And I'm making sure that it is not checked. That's basically it. And final thing, I want to make sure that the register button is disabled. And I do that by finding a button with a text register and make sure that it is disabled. So this is what I want on startup. Obviously, next tests are going to be about interaction, behavior of interaction. So what do I check there? Then this is like a bit more complex. At the beginning, first of all, apart from the user testing library, I'm using also the user event. Well, let me show you where I import that here. A part of the testing library is the user event, which kind of mimics what the user does when it interacts with checkboxes or buttons or text boxes. It sends all the events that HTML events like mouse down, mouse up that happens. So if we want to check behavior or our code responds to this kind of behavior, we actually want to do that. So yeah, we have a user, we have a mock event handler. Remember, this simulates what the page, the container will actually get. And this is important for us because we might be wondering what kind of data is going to be sent outside. And then I'm rendering the registration and finding all the locators so I can actually work with them. So the first test is that checks that the register button is enabled when I'm clicking this thing here. So I'm clicking the checkbox and it is enabled. Great. I also want to make sure that when I unclick it or click it again, it gets disabled. Now everything starts from the startup position. So in order to simulate that, I actually need to simulate the user's behavior, which means I'm going to click it twice, like I did. And then make sure the registration button is disabled. And that's about what I can do with the register button, except when clicking it at the end, for empty boxes. Next I want to do is look at the error. So if I actually did that, remember, if I do this, there's an error here. And I want to make sure that the error is appearing. So what I do is make sure I'm clicking the term checkbox, clicking the button. Remember, these are empty, so it will show the error. And this is like the dynamic nature of HTML because we can actually change the HTML document. So the model is changed, and now it contains something, the error box, the error div, that it didn't contain before. So the whole thing looks like it's actually a step-by-step thing, but it doesn't have to be like synchronized. So this is why we're using things like await in the code. So basically what Playwright and React Testing Library do is kind of hold the waiting things for them. So when I'm saying find by text, it actually waits until some kind of timeout to look for text to appear. If it finds it, great. If it doesn't, it will throw a timeout error, so it's not there. And when we're thinking about web testing, need to get into this mindset that we might be looking for things that haven't appeared yet or have gone somewhere else while we were talking. So anyway, I'm looking for this element, the error message to appear, to be in the document. I can also check things that like this is like you don't see it too much, but it is red. So I can check that an error appears as red. I can check all kinds of things. It doesn't actually tell me that it is red. Like if you see on the screen right now, it's saying, well, is this red? Is he lying to us? Actually, it is red, but it is declared as a class name which contains red. But it doesn't check how it looks like. It checks if the HTML created by this contains the class name red, which is like sometimes it's good enough, sometimes it's not good enough. You have a problem like testing visually in this case. Okay, what else? It hides the errors. And remember that when I start typing here, like doing something here, the error disappears. So I want to simulate that too. And I could do that also the Playwright or the entire web test level as well. But it will take a lot of things. It will be a lot slower than actually working with that. So I'd rather, if I can do this, I can do this at the component level. I really would try to do this. And this is how I do it. I'm clicking twice. I'm clicking the term box, clicking the registration button, creating the error. You don't see it here, but we both know that at some point here, an error appears. This is something that I'm not going to talk about today, but this is kind of hiding information in the test. We know this, and I explained this to you, and we've seen it. Reading it from the code, the code or the test doesn't really tell us what's actually happening here. We need to like interpret what actually happening in order to understand the test. And as opposed to like the unit test, like it checks functions that we can look at and see what happens. You kind of have a missing block here, like what we actually see. Not for today, though. We're not talking about this today, but this is a problem that when we're talking about writing good tests for web tests, we need to be aware of that and make sure that we write more clearly. Probably a webinar that's coming up. Anyway, I click the term box, I clicked the register button, and an error appeared eventually somewhere. And then I'm typing in some kind of input into the first box. It would be S. And then I'm going to check for the text. Remember, the text is, should have disappeared by now. So the find methods will not find it and will throw an exception. So in order to find something that we don't expect to find, there's an API called query. Find something that looks like this text, and then make sure that it's not in the document. This is how we make sure that the test passes when it needs to. Final thing happens is that I want to make sure that after I fill this correctly and I click register, remember the component itself does not talk to the database. So what it does is send the data back to its container. So I want to check that. And the way to do this is basically fill the boxes. Remember, the term checkbox needs to be disabled, but it's not information that's going to be sent up. It's just for enabling and disabling the register button. I am interested, though, in if someone checked I want to get promotions because I want to give him some kind of promotions. So I want, and the event handlers basically has two methods. I haven't showed you that, so let's look at the registration. You will see that better in the page. The page. Not the thank you page though, registration page. You'll see that the event handler has two methods. One is the details class, the first name, last name, and email. And the second is a Boolean whether promotion was clicked or not. Or do we want promotions or not? So at the component level, we just need to make sure that things were sent correctly. What does it mean say correctly? So we're filling the details as I want them. I'm also clicking the promotion box to see that it will send true rather than false, because I want to make sure that it actually does something. And when I do that, I'm clicking the registration button, which causes the event to be sent, and then the event handler, remember the fake one, this one, it's a mock event handler to be called. So I want to make sure that it was called once, obviously, and that I'm grabbing the arguments from the call. What you see here is basically give me the first call. There was only one, and give me the first argument from that. And the second one's give me the second argument from the first call. We have the details, we have the promotions, and we can check that the details is this object of what I sent, the data, and promotions to be falsy because I clicked on it. Remember, it comes up true, so now it's going to be falsy. So now I couldn't do that, and some people would say you probably shouldn't do that at the page level, right? The concept of event disappears, and when we're talking about like full page, well, there's going to be a script there that runs, but there's nothing connecting the register button or something like that directly. There's going to be an on-click, which runs a submit, but I'm not sure how it's going to work because the generation of the HTML and the JavaScript is out of my hands. Here, I can actually say that, well, you know what? This component sends the data correctly. And if this component appears in other pages as well, I know that it will work for any container. Final thing here I do is clean up. This is something you have to do in order to remove all kinds of garbage from the test rendering before you move into the next test one. Final thing is the end-to-end test flag. So, but before we do that, remember, we have a thank you page, which looks like this. Remember this? So this is the thank you page. But if you look at the code, you'll see that if I actually do this, I'll go to the thank you page and will not send anything. It will not because the demo is, oh, you'll see that it changes to who are you, which is the error text. So the code expects is that the page will be passed. What you see here is a query parameter with name equals Gil as before, like takes it from the data and sends it. But there's other pieces of code here which kind of creates the error message if it doesn't find the query parameter. I want to check that too. This is like checking the entire page, right? So I can do that. I can do that also in testing library if I want to, but it makes sense to test the page. And I'll use Playwright to do that as well. So so in Playwright, they seem kind of similar to vtest, but this is really Playwright. So the test is really test Playwright. And so this one checks that I'm going, like, if I'm going, and both are configured to run on HTTP localhost 3000 port. This is why you only see the relative URLs. So if I'm going with thank you and name equals Gil, it will show you the thank you Gil is visible. But if you're just sending in thank you without the query parameter name, it will show you the thank you error text. Wow. So I can check that as well. And this is like, we're thinking about full application end to end. This is actually like a component test, if you think about it. Only slower, but it checks an entire page. But it's part of the application. Not it would be like part of the workflow. When we think about like whole flows, like nobody will, in their right mind, will go into the thank you page and use it like that. But there is some kind of behavior that I'd like to check that. So I can check it with this. Obviously, I want to check the whole registration process, and a couple of things there. I want to check that the registration page opens correctly. What is correctly? This is the whole page. So this is where we can think about the business requirements and translate them into what I want. So I want to make sure that the title is in place. Remember, we haven't checked that at the component level because it wasn't there. Title is part of the page, not a component. And I also want to make sure that the promotion checkbox is checked because there's a business requirement for that. And I want to make sure that the button is disabled. These things, get title, get promotion checkbox, I just moved them into the common thing. It's page by role. These are kind of similar things to what we saw in the testing library, finding locators on the page. So once we do that, we know that the page loaded correctly. There is some similarity and maybe some overlapping in what I'm testing, like in the next one. If errors are really important to me, I may decide to test them at the page level. So I will go to the registration page, click the terms checkbox and hit the button. Remember, this is what simulating that the text boxes are empty, leaving them empty, and then making sure that the error message is visible. Let's see if I can show you when it runs. I'm not sure you can see. It's still running. Thank you. But you don't see because it opened a browser and yeah, trust me, it works. And it just finishes up in showing the error. So it actually creates its own browser and runs it there. And of course passes. You see that it works. The final one is to actually check the end-to-end thing, right? So we go to the page, to the registration page, click the terms checkbox, fill up the names, and hit the button and expect and make sure that we've gone on to the thank you page and it shows us thank you, Gil, which of course works, but let's see if it actually does work, but you may not see it. We're waiting for the result, running, blah, 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 blah. And we're done. So, and like 25 seconds, right? So we can do this, like all the tests that we've done, like from most of the things from the UI, but like this is one test. Takes a lot of time. These things compound. So using low-level tests are easier. By the way, let me show you. I'm going to run the unit tests and the component tests. So this runs the validation tests and the component test. Everything that I showed you. Yes, it loads slowly. Then at one point, thank you for the messages. Please run. Thank you. So once it's running, it's pretty quick. Yes, it needs to load everything, but yeah, you can see that you want to run as many tests as you can, and the lower level tests are actually cheaper to run. And it's good to have something that's running this quickly, hopefully even more quickly. Okay, so we have an end-to-end thing running, which is cool. And remember our question at the beginning, so does it really work? And the answer is we don't know yet. We need to look inside the database. Now, this test run locally, the database runs locally, can actually look at the file. I showed you the file and see if something happened. But if I'm writing a true automated test, I would actually want to either look into the database or maybe do something else, like expose an API that can bring the information for me, especially if I'm working like more cloudy environment. So let's look at the code again. And this is more robust process. Everything here checks out the entire process that we saw before. But I've actually created a helper API that will read everything from the database and bring it to me in terms of JSON. So my code, after that, I'm calling the API, creating my API, get the JSON out, and make sure that the final entry in the array, because it returns everything as an array, is what I'm actually doing. So this will be like the final thing in terms of, remember, this one actually calls the database. Our tests that we run now as pages, they were actually running the database. Look at the code, at the database, you see that we've added a couple of those things because of the tests as we were running them. So our test really checks that the last thing that was entered, because we entered it, was the right thing to do. It's not the perfect thing, but it's a lot more robust than what we have. So to summarize, what is web testing? So web testing really is testing, but in a web context. So if you think about the tools and the framework, yes, they are different from what you're used to if you haven't touched them before. But you have like a test framework, you have mocking, and you have test engines, and you have drivers like in Selenium and Chrome driver and stuff like that for the browsers. So there are tools that automate stuff. Some of them come with all kinds of asserts, expects. So this probably is new if you're entering the web world. However, everything else really is the same. You still have to do planning. You still have to do test design. You still have to understand the architecture and how things are built in order for designing the right test. You need to do refactoring. You need to have better names. You need to organize your tests in a way that they won't conflict with each other. You have to understand dependencies, what you're running and what you're running in parallel. All these things is basically testing. It's what we used to think about, or we need to think about when we're doing test automation. So web testing is, the technology may be different and how it works may be different. And there are definitely things to learn and how to do things well. But everything else from maintenance to writing better tests and readable tests, they're still there. So really web testing is like everything testing that we do know, only in a different context that we are used to. So I'm done explaining to you and web explaining to you everything about what web testing is, and I hope it was helpful to you to understand how to approach web testing. It's not about like yes, maybe things like were new to you in terms of tools, technology, but the thinking. This is what it's a lot more important. How to think, how to approach testing. Understand what are the differences from like API testing, unit tests, but also to understand that some of these things we take from however we tested before, and we can still apply them to web testing as well, maybe a bit differently. That's what I wanted to share with you today. If you have questions, please write them in the chat box or the Q&A box. Otherwise, you can get in touch with me with all the things that you see on the screen. Check out the YouTube channel. There's something coming up almost every week, including these webinars, a lot of short videos that we're doing in all kinds of types of testing and testing material, not just testing. Last one was continuous integration, data-driven tests, all kinds of things that are around making software better. Okay, there's a question. How do you consider testing edge cases like DB not available? Okay, so let's think about it this way. Okay, so what is DB not available? Database not available. So first of all, I need to make, like, let's say, okay, so this is like very small question with a very big answer. What does it mean that the DB is not available, the database is not available? I'm expecting some kind of behavior from the system because me or somebody else actually wrote some code to handle this kind of situation. Even if they didn't, and somebody else takes care of that, like, I don't know. We have a gateway that we're using that our team is not in charge of completely, and it will check that the database is not there and will give some kind of error. But let's say there is some kind of behavior I expect from the system. So now there are two things to do. One, to create a situation where the database will not be available. And the next is to check that the behavior that I expect actually happened. We can do this in all kinds of ways because this is exactly like we're trying to think about in regular testing. Like if you're testing APIs, how do you make the database go away? You can make the database go away like with scissors, or you can mock the database behavior or go somewhere else where there isn't a database, an empty database, one that doesn't answer. You can do all kinds of things and then check that the code that handles this misbehavior behaves correctly. How do you do that? Again, either you'll see something on the screen, the effect of like, I can't access the database for more than 5 minutes now, or it's not possible. And what you see is something like a spinner spinning on the screen because something happens in the backend. Usually that's not a very the very behavior that you actually want to have in your system, and therefore you might not think about checking this thing. But if you're deciding that the spinner is spinning, you can check that on the screen. You can also check that, I don't know, if there was a general error appearing on the screen, but you actually want to check that database has malfunctioned. You can do this either by trying to connect from the test to the database or an API that will tell you what is the status of the database. These are like the same ideas that we use everywhere else. We're trying to simulate the situation or create the situation, produce the situation, and then look at what we know is the impact of this thing, because somebody has written some code that handles this thing. So I need to set up the thing and find out what I need to look at in order to see that this thing has worked correctly. The database has malfunctioned, but somebody identified this and reacted correctly. So yeah, that like I said, a very long answer to that. Sure. If you wake up somewhere in the night and you have a question, this is how you get in touch with me. All kinds of social networks and emails and stuff like that, and through the site. If you want my help with thinking about implementing testing, unit testing, API testing, whatever, web testing at your team, how to implement that, how to roll this out, let me know and I hope I can help you. Thanks for coming today, and I will see you in the next webinar. Bye-bye.